My name is Eiji. I'm a developer advocate working on identity on the web at Google. So do you have a phone today? Right? Every one of you here should have a phone. So owning a phone means that, I assume that, sorry. Owning a phone means that each of you have your own personal phone number. Interesting thing is that even if you own a phone, maybe you're not making a phone call every day, right? You still call it a phone. And the phone numbers are still playing a very important role in your daily life. For example, phone numbers can be used as a digital identifier and a personal communication channel. Some web services use phone numbers to create online accounts or to build social graph. As a personal communication channel, of course, you make phone calls, and you can send text messages. And there are a lot of online services that heavily rely on phone numbers, especially as a way to send SMS text messages. These services are using SMS to let users sign up, help users recover their accounts, increase user security with two-step verification, or confirm payments. This kind of SMS usage is very popular, especially in countries like India, but also worldwide. In a typical user experience, an SMS is used to deliver a one-time password, OTP. The user verifies ownership of their phone number by passing the OTP back to the service. But the challenge is, this can introduce some friction to their user experience. To enter an OTP, the user has to open the SMS app. Then remember or copy the OTP from the message, go back to the website, and enter that into the form. It's so easy to make mistakes, and sometimes you have to request a resend. That's why we are proposing a new API called SMS Receiver API. Web developers can use the SMS Receiver API to let the browser receive the SMS message, extract the OTP, and enter the OTP on behalf of the user. For end users, entering the OTP can be as simple as one tap. And we have a few websites that are experimenting with this API already. Swiggy, India's largest on-demand food delivery platform, achieved a sign-in success rate of 88%. This number is on par with that of their native app. Myntra, a fashion e-commerce player in India, decreased the drop-off rate while signing in by 38%. Oyo, a hotel booking service, succeeded in reducing time to login by 42%. These are all impressive numbers, and there are more companies trying out this API. Now, let me talk about the code. Before the website can receive an SMS, you have to know the user's phone number so that you can send a message. If you are using an input tag, my recommendation is to use autocomplete = tell. That way, the browser can help the user autofill their phone number. Giving your website the ability to send an SMS might seem a bit scary at first. What if someone builds a bot and spam random numbers? To mitigate such abuse, you can use a service like reCAPTCHA. Especially with reCAPTCHA v3, that lets you identify bots without requiring user to check a box or solve a puzzle, like picking traffic light images. To send SMS messages, you can use your existing infrastructure or just rely on a third-party service like Twilio, Nexmo, Telesign, or another SMS gateway. Using the SMS Receiver API itself is as simple as one line of code. When you call Navigator SMS Receive, the browser waits for an SMS. Behind the scenes, we are using Android's native SMS Retriever API to access the incoming message. Chrome is one of the consumers of the API, and the message will not be delivered to the website unless it meets certain conditions. The text message needs to include the URL of the origin to which the SMS is sent, Chrome's application hash, and the OTP. However, as we are experimenting with this feature and the API design is subject to change, I won't go into detail about how to format the SMS. You can check the format, latest format in the article I will show you later. When an SMS is received and meets all the conditions, a bottom sheet appears in the browser. And the user can grant the browser permission to access the text message. This permission is required for every receipt of a new message. This means the browser won't be able to read SMS messages without the user's explicit permission. In the current API design, you will obtain the entire text message. So you can use a regular expression to extract the OTP. After extracting the OTP, you can either enter it in the form for the user to submit or post it directly to the server-side verification. To learn more about the SMS Receiver API, please go to Google/SMS Receiver API. The article has details about format conventions and how to implement the API. The SMS Receiver API is still experimental. You can use it under origin trial, which means you need to submit a request to whitelist your domain, accepting that the API may change in the future. The article has information about how to sign up to the origin trial. I bet you have tons of questions about this API, and I hope we have successfully addressed most of them in this article. But let me highlight one outstanding question. Is it safe to use SMS as a way to authenticate a user? It's a great question. The short answer is be careful. Browsers enabling this API doesn't mean that we recommend you to stop using the existing way of authentication. The reality is that many websites already use SMS as a way for their authentication with their users. However, phone numbers are known to be hijackable and to be recycled by phone carriers. In some cases, users have been the victims of SMS phishing attacks. We recommend using SMS as an additional factor for something else, for example, a password for authentication. But in a world where you can expect many users to have a biometric sensor on their device, we suggest something even better, which is Web Authentication API. In other words, WebAuthn. We covered WebAuthn at Google I/O this year and last year. But I would like to recap a little bit about it in case there are people not familiar with it. WebAuthn is a standard browser API that enables strong authentication on the web. It's supported by all major browsers, at least partially. by using a piece of hardware which we call the Authenticator. End users can register for and authenticate with a service much more safely than before. WebAuthn is based on a public key cryptography. A user can register an authenticator with a website by generating a key pair, keeping the private key in the authenticator, and handing the public key to the website. Upon signing in, the authenticator can generate a unique signature so that the user can prove to the website that authenticator is present. In the previous session, Emily showed you how Chrome tries to ensure the user is on a genuine site. WebAuthn allows you to provide an extra layer of safety for users. Because the key pair is bound to the website's origin, even if a user ends up on a phishing website, that phishing website will not be able to make the user generate a valid signature, which saves their users. Now, I would like to talk about two primary user experiences using WebAuthn. They are two-factor authentication and re-authentication. Let me start with two-factor authentication. Because an authenticator can prove your presence by combining it with a password, you can perform two-factor authentication for users. That's the basic idea. Let's have a look at a real-world example. GitHub offers two-factor authentication as an option. You start by entering your username and the password. When you see this screen, get your security key. A security key is one form factor of authenticators I mentioned earlier. Click the button, and you'll see a browser's native dialog. Use your security key and perform a gesture on it. The gesture depends on the authenticator you are using. But for typical security keys, simply touch it. If the security key is already registered to the service, you are signed in. Imagine how it compares to entering an OTP manually. It's much easier. So how do I register a security key? To register one on GitHub, go to the security page. You'll be asked to name the security key you are adding. Name it and press Add. Then you can register your security key by touching it. Now your security key is registered. You may add multiple security keys as backups. So naming it helps you find the right one. Imagine if you lose your security key, or break it, or even lost. You can revoke the key from here and invalidate it. So how effective are second factors? Here's a comparison between SMS OTP as a second factor and security key as a second factor. As you can see, SMS OTP is not perfect against targeted attacks, while security key protects users completely. Targeted attacks are a specially crafted phishing email aiming at a certain company or an organization, for example. So two-factor authentication with a security key works quite well. Now, how do we implement two-factor authentication using WebAuthn? The first thing you should do is to check whether WebAuthn is available on the browser. You can do so by checking if public key credential is available. To register a new credential, call navigator-credentials.create. This will cause the browser to start waiting for user's gesture on the connected authenticator. Upon the authenticator's response, you will receive a credential, which includes a public key and an ID for the credential. Send the credential to the server and store it for future authentication. Now that you have your user's authenticator successfully registered, how does authentication work? After the user enters their username and their password, you will ask for second factor. Use navigator credentials.get for authentication. For this call, you must retrieve all of the user's registered credential IDs from the server and provide them to the browser in allow credentials. That way, the browser can detect which authenticator to use. Again, the user performs a gesture on the authenticator, then you will receive a credential that contains a signature. The most important part of WebAuthn is to verify the signature on the server side. You should use a FIDO server to do this validation on the backend. I would recommend that you use a trusted third-party service or a FIDO certified server. I will come back to this topic later in this session. I have mentioned authenticators many times in this session so far. But what exactly are authenticators? And what kind of authenticators do you need to have on hand for development, or assume users might be using? For two-factor authentication, users can use authenticators that are marked as U2F or FIDO2. As I said, security keys are the most typical form factor for two-factor authentication. They are also known as roaming authenticators. Roaming authenticators can be hooked into your computer or smartphone using USB, BLE, or NFC. One caveat about security keys is that many of them come with a metal plate on it. Some people might think that this plate is a fingerprint sensor, but in many cases, it is not. When you are buying a security key, please be careful about that. By the way, how many of you here have a security key? A lot of you, but I see some of you don't. You learned about WebAuthn today, and you're excited to try it, right? But you don't have a security key. You need one, don't you? So, a good news is that we have this security key to give away. Please visit the Developer Sandbox. There's an Identity, Security, and Privacy Developer Sandbox. So you can go there to pick yours. Thank you. And there is another kind of authenticator built directly into your computer or smartphone called Platform Authenticator. Platform authenticators are more consumer-friendly than roaming authenticator or security keys because you don't have to purchase a separate device. You don't have to worry about carrying it around. And they are a part of the device you use every day. And many platform authenticators come with a biometric sensor, such as a fingerprint sensor or a facial recognition sensor. Users can also use the platform's screen lock feature to verify their identity. Some people may worry that this means that their fingerprint is sent to the website and may somehow be stolen, right? But don't worry. Important secrets, such as biometric data or screen lock patterns, are stored only locally, which means user verification is done entirely on the device. We call this local user verification. This also means that every new device that the user signs in on must be registered. Platform authenticators that have the local user verification ability, or I would say most of them, are specifically called user verifying platform authenticators. So the second use case of WebAuthn is re-authentication. Re-authentication is a user experience where a user is already signed in, but gets a request to authenticate again when they come back to the website after the session is expired, or when a sensitive operation, such as changing a password or making a payment, is being performed. A common way to perform re-auth is to ask the user's password again. But with WebAuthn and User Verifying Platform Authenticator, the user experience can be really snappy. Let's see how Yahoo Japan integrated re-auth user experience. When you are signing in, start with your username. After you submit your username, the browser's native dialog pops up. The user can verify their identity locally with a fingerprint sensor, for example. Once verified, you are already signed in. This fancy UX is also preceded by a registration. Because Yahoo Japan is already passwordless, I'm signing into their service using SMS OTP without a password. After successfully signing in with your username and an OTP, you will be prompted to register the device. Again, perform local user verification. Just like we did for the two-factor authentication with GitHub, the service asks you to name the device so that you can identify it if you need to remove it later on. And your device is registered. Moving forward, you can use this device to log in to Yahoo Japan using local user verification. By the way, have you got a Pixel 4? Some of you, right? Pixel 4 has a new shiny facial recognition capability. And some of you might have tried it with WebAuthn, with Pixel 4, and so that it doesn't work yet. But the good news is that starting from Chrome 79 and an update to the Google Play services, it will be possible. And I'm going to demo it for you right now. OK, so what I'm going to show you is a re-auth user experience at passwords.google.com. Passwords.google.com is a page where you can view the password you stored to Chrome if they are synchronized with your Google account. As you open an individual password entry, you'll be asked to do a re-auth. And if you are using a user verifying platform authenticator, like Pixel phones, you will do a local user verification. So let me try one of the passwords here. By pressing it, intentionally, I'm not going to show my face at first, right? So by pressing, it's asking to verify my identity. By pressing it, it shows a fancy UI with a face. But because I was away and not showing my face, it failed. But let me try again with my face revealed to the phone. See, that guy winked. It's cute. And I'm confirmed and successfully able to view my password. OK, go back to the slide, please. Yeah. So it's really nice user experience. You don't have to type much, right? You don't have to type your password. And with local user verification, we have seen about 63% improvement in time to log in, comparing to that of re-authentication with a password. It has significant user experience benefit for end users. And here's how to implement this feature on your website. After feature detection, check if a user has a local, user verifying platform authenticator using a function called is user verifying platform authenticator available. That is very long function name. I believe this is one of the longest, not one of the longest function name in browser API. But anyway, with this check, you ensure that the user's environment is capable of the re-auth user experience you are about to perform. Call navigator credentials.create to register the user verifying platform authenticator. This is the same function you called to register two-factor authentication. But you need to specify a couple of specific options. Set authenticator attachment to platform. This restricts registration to platform authenticators. Roaming authenticators won't be registered. Set user verification to required. This ensures that the authenticator being registered is capable of local user verification. As soon as the function is called, the browser starts to wait for a gesture on the platform authenticator, in this case, local user verification. When you get the returned credential, send it to the server and store the credential, just like you've done for two-factor authentication. To allow the user to re-authenticate, you also need to store the credential ID on the client side. You can do this with using a cookie or local storage, and the registration is done. When the user comes back, run the same feature detection as you did during registration. However, in this case, make sure that the user can fall back to use other means of user verification, for example, using a password. To authenticate the user, call navigator credentials.get. For this call, set the option user verification to be true. And in allow credentials, include the credential ID you stored locally during registration. As soon as you receive a credential, make sure to verify it on the server side. Once verified, the user is successfully signed in. This is how you implement a re-authentication user experience using WebAuthn. You can start learning about web authentication from Google/FIDO. If you're interested in more nitty-gritty about implementing WebAuthn, there's some awesome documentation written by folks at Duo Security at webauthn.guide. If you're interested in implementing the re-auth user experience, go to Google/WebAuthn re-auth code lab, which I hope it will help you ramp up with learning WebAuthn. Regarding the FIDO server, there are quite a few solutions available in the wild. You can check FIDO Alliance certified servers on their official website. Also, there's a list of open source servers and other resources as well. We'd like to also collect your interest in a cloud solution for FIDO servers. Please drop a line on sso@google.com or just visit the developer sandbox and let us know. Let me recap. In this session, you have learned two technologies. SMS Receiver API eliminates the friction of entering SMS OTP. It's under origin trial. We are looking for your feedback on the API. We recommend two user experience flows using WebAuthn. One is two-factor authentication, which works best with security keys or roaming authenticators. The other is re-authentication, which works best with user verifying platform authenticators. I and a bunch of experts on this area will be waiting for you at the developer sandbox. Please come and say hi, and please give us a feedback about our APIs and ask questions, not just to pick up the security key. I hope you'll enjoy the rest of Chrome Dev Summit. Thank you.